Hi guys, in this video we will work on integration practice problems, and we will do these based on all the concepts we have learned up to this point. So the first integral I want to talk about is a trigonometric integral, and it is going to be the integral of secant x tangent x dx. Now, if we think back to our trigonometric video, we know that d dx of secant x equals secant x times tangent x. And therefore, the integral of secant x tangent x dx must equal secant x plus c. And that is our answer. So that's the first integral. The second integral I want to do is the integral of 2 to the t plus e to the pi dt. Now, don't get thrown off by t and dt. It just means any other variable I'm integrating. So, for this question, let's think about what we have. Well, first I can see that I have this exponential function here. And here I can see I have a constant. Now, before we go into this integral, let's break it up using the sum and difference rule. So I'll have the integral of 2 to the t dt plus the integral of e to the pi dt. Now notice the integral of 2 to the t dt. We know that that is our common integral of a to the x, and we know that the integral of a to the x dx is equal to a to the x over ln a. So therefore, the integral of 2 to the t dt must be equal to 2 to the t over ln of 2. Now, regarding this other integral, well, we know that e to the pi is just simply a constant. And when I integrate a constant, all I have to do is add on the variable to the end of it. So this is going to be e to the pi times t. And I always add on my constant of integration. So that is going to be the answer for my second integral. Now, the third one that I want to talk about is the integral of 5e to the 2x plus 1 over x dx. Well, firstly, let's break this up. So I have the integral of 5e to the 2x dx plus the integral of 1 over x dx. Well, at first glance, you may think, I can use the power rule on this because it's x to the negative 1. But remember one key thing about the power rule. It works for all exponents where n does not equal negative 1. But here we do have negative 1, so we cannot use the power rule. And we actually have to remember that this is a common integral. And specifically, the integral of 1 over x dx equals the ln of the absolute value of x. Okay? Now, we are going to try and integrate 5e to the 2x. Well, regarding 5e to the 2x dx, I can pull out that 5 and rewrite it as 5 times the integral of e to the 2x dx. And for e to the 2x dx, I want to mention another common integral that we previously missed in our last videos. And it's the integral of e to the ax dx, where a is some constant, equals 1 over a times e to the ax plus c. Okay? So now I'm going to go back to this. Well, if that's true, then the integral of e to the 2x dx equals 1/2 times e to the 2x. And I still have that 5 there, so this is going to be 5/2 e to the 2x. I still have that ln x plus ln x, and you cannot forget to add on a plus c. And that's the result for my third integral. Now, our last integral is going to be the integral of x cubed plus 5 over x squared dx. Okay. So the first thing I notice is that I can divide both of these terms by x squared. So I'm going to rewrite this as being equal to the integral of x cubed over x squared plus 5 over x squared dx. Now, I can break this up and simplify, so this is going to equal the integral of x cubed over x squared dx plus, and I'm going to take out this 5 instantly, 5 times the integral of 1 over x squared dx. Now, this x cubed over x squared simplifies to simply x, so I have the integral of x dx. And remember, there's an imaginary 1 on that x. And now plus 5, and I'm going to rewrite this in exponential form, which is going to be in the form of x to the negative 2 dx. Now, simply, I just have to use the power rule. This is going to be equal to 1/2 x squared minus 5 over x, because the integral of x to the negative 2 is x to the negative 1 over negative 1, or negative 1 over x. And then you can never forget to add on that c. And there are our 4 integrals and their answers. Stay tuned for next video, because in next video we will get into integration with u substitution.